All right, people. We have now completed our international conflicts lesson, and that is it for civics. Like, that was our last lesson. Normally, under normal circumstances, we would have about 2 weeks of classes left together. And in those 2 weeks, I use geography lessons with you. And I love geography. I taught it for a number of years. I taught it to you a little bit this year, here and there. And usually those last 2 weeks of school is we do it together. Now, the majority of what we do in the geography lesson is in class. We do it together because, well, I want to be there to help you. So what I want you to do is, hopefully you're watching this video right now, I'm going to introduce to you the first activity that we have, which I also attached to this morning's Edsby message for all of you. And I'm going to go over what I want you to do. So as you have already seen, I always start geography off with latitude and longitude. Lat and long, coordinates, location on this planet. That's the number one question when it comes to geography is where. Where is this? Where is that? Where is this? Where is this person? Where's this place? Where's this city? Or where is this happening? Or where is this occurring? That's always what I wonder when I read about the news, or I hear a name of like a city or a place or a person. I'm like, where is this place? Like, where are they from? This and that. So it's definitely something I'm very passionate about, as I'm sure a lot of you have picked up on. So how we figured out where things are, we have developed since the dawn of the Greek civilization, is the use of what's called latitude and longitude coordinates. Latitude lines are here on the left. Longitude lines are here on the right. When you combine the two of them, you have what is called a grid. And on that grid is how we pinpoint places on a map. Now today we have the technology to pinpoint all these places, and that is what Google Maps and GPS systems all use, is they use precise mathematical coordinates that are using latitude and longitude. But what I want to do with you today is, and I'll get into it in just a second, is I want you to do it on your own. But first, let me explain exactly how latitude and longitude work. Latitude is over here on the left, and that technically was invented first by none other than yours truly, the ancient Greeks. Because when you look at the globe, it's pretty easy to split it in half, right? Like, you can find the middle of the earth going left and right. See? You could find it right here. So when you say halfway, that's the equator. And the equator basically is the halfway point, but going one direction, north to south, right? And that's latitude lines. They run north and south. As I like to say, lat is flat. Latitude lines are the flat lines. Now here's the trick. They may run left to right, as you can see, but technically they increase north to south, up and down. You got me? So that's where we come here. Take a look. Latitude lines go from 0 degrees in the equator, and they go up to 60, all the way up to the top of the earth, the North Pole, which is the highest point, obviously, 90 degrees. 90, 90, what do you get? 180, circumference of a circle. Going the other direction, you go south, as you could see. Think of it as like math and a number line. You know, same numbers, positives and negatives. Think of it like that. But when you go south, you're now in the negative. Negative 30, negative 60, negative 90. Now, on a computer system, which I'm sure some of you will use here and for this activity, you will notice that the coordinates will have the negative sign there. That indicates it is south. All right, it is south. So latitude lines, they go north and they go south. And the equator is our main basis of latitude. And that's like our That is like our relative point. It's like, how far are we from the equator? How far are we from this? How far are we from that? Blah, blah, blah. By the way, on a map, the distance between each latitude line, right? So if you go from this line to that line to that line, is approximately 69 or 70 miles, nautical miles, which is basically the same as a regular mile or whatever. So technically on a map, they're about 70 miles apart. Okay, that brings us over here to longitude. Longitude, how I remember them, they run long ways, as you can see. They run north to south. But once again, here's the trick. You read them east to west, east to west, left to right. So they literally run north to south, but you read them east to west. So they're your second coordinate. You'll get your latitude coordinates first, then you'll get your longitude coordinates. So as you can see right here, let me move myself out of the way. As you can see right here, here are your longitude lines. And you read them from east to west all around the globe. Here's a great question though. How exactly do you find the halfway point, right? When you're looking around the earth as a circle, there really is no halfway point until someone decides that this is the halfway point, right? That halfway point is known as the prime meridian. That is 0 degrees longitude, right here, as you can see, 0 degrees longitude, okay? That is the main line of longitude, where the equator and the prime meridian meet is 0, 0. And that is on all flat maps, because most maps are all flat, right? That is going to be dead center of the earth. But I mentioned this to you one before, when you flatten out a globe, the map is going to be wrong. There's going to be a lot of flaws with it, such as distance, size, and things like that. But technically, where those two lines intersect, the prime meridian and the equator, 0, 0. And that's technically the center of the globe. But as you can see, here's the prime meridian, right? It's going right through Africa, up through Europe a little bit, and goes all the way top to bottom. Well, who made it that point, right? I'll let you figure that out on your own. Now, let's take a look at what I want you guys to do today. Here's your worksheet. Now, this is going to work best if you print this out and do it yourself, okay? And the reason why is you guys are at home, you're on your computers, you can easily look up these coordinates going into Google Maps, but you're not really going to learn much by doing that. When you do it hands-on, and that's why I saved geography for these last 2 days, today and tomorrow, before your test on Friday, because most of what we do for this unit is in person, and I work with you in class. So help me out a little bit here. If you could print this out, wonderful. If you can't print it, then use your mouse cursor just like I am here. And I want you to find these coordinates and plot them yourself. You can literally do it by, inserting a shape or a dot or something you can draw on the map. And you can check your answers by going to latinlong.net or a simple Latin long calculator on the internet. But just do me a favor and try and do this on your own. Try and find these locations on the map, their precise location. By the way, coordinates that you receive, as you can see here. So let's look at New York. By the way, these are cities, so this is New York City. 40 degrees, 45 north. Latitude's first, and then longitude is second. W, as you can see, west. Looks like I gave you everything west of the prime meridian, so, oh well. I have a whole bunch more that I can give you. In fact, I think I will, there's probably another attachment to this here that I'll show you guys, and you guys can do on your own. So latitude is first, longitude is second. And I'm asking you to mark these cities on the map in color. So make this city red, 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 whatever you want to do. But I want you to do that for me and do me a favor and plot them yourself. Don't just simply like, well, you can play around with Google Maps. I implore you. I love Google Maps. I play on it all the time. And you can double check your answers that way. But remember that this map here that I've given you, okay, this map is characteristic of these coordinates. If you were to go on to another map online or another one on the wall, you know, the coordinates are going to be a little different because they're not the same map, which is why we have GPS. GPS uses the exact mathematical coordinates. But this activity is about you guys plotting these points on your own. So please go ahead and do that on your own. And I hope that this video was helpful.